So another important and a very general question asked by the students: why light bends when refraction takes place? So one child of class 10 was asking me this question, that why light bends when refraction takes place. I am discussing it in class 12 also because I felt that the reasoning should be explained to both class 10 as well as class 12. So the question is why light bends during refraction, while means when the light travels from one medium to another. So in class 10 also and in class 12 also we learned that when light moves from one optical medium, suppose this one is medium 1 and this one is a rarer medium and it is going to a denser medium. Very simple, the speed of the light is going to be reduced. Here we know that when the ray of light is moving from an optically rarer medium to an optically denser medium, the speed of the light is going to be reduced. But the question is why the light is going to deviate from its path, bend from its path. That is the question. Speed might be reduced. The speed might be previously 20 meters per second, now it is 5 meters per second. But why it is going to bend its path? So over here, the explanation of this question is, we generally treat light to be as a point particle, and this point particle is moving in this straight path. Okay? But light has various properties. Light is also a wave. Okay? But if we consider light to be as an extended object, not as a point object, as an extended object. So see how does it happen. So suppose this one is a road, and there is a car. This one is a car. There are the two wheels of the car. Okay, and this one is the interface. This one is an oblique interface. This one is a plain road, and here is a bumpy road. And the car is coming like this. So you can see at this very particular position, this wheel is going to reach the point over here earlier. And this point is going to reach a later. Okay. So as soon as this point A reaches this point over here at A dash, the velocity of this point is being reduced, but the velocity of this point is yet continuing in its original pace. Okay. So when it reaches over here, the distance of separation between these two wheels is like this. Okay, it is oblique. The first wheel is reaching the ground over here. Its speed becomes lower, while this wheel is still in the first medium. So it is moving with the same speed as it was going on, and it is moving at a larger distance than this one. So when it is touching this particular pace, the distance of separation is oblique. You see, the distance of separation over here is straight, but when it reaches over here, the distance of separation is oblique. Okay, so it is bending. It is lower horizon. So when we are treating light to be as an extended particle, it doesn't mean that if this point has reached the second medium, this particle has also reached the second medium. No, it might not happen. Okay? So, the ray of light when it is entering into the second medium, it might happen that this particle has reached, this particle is somewhere over here, this particle is somewhere over here, and this particle is somewhere over here. So, the distance of separation between all these particles is not in a straight line, but it is in an oblique manner. So when light moves from one optically rarer medium to a denser medium, it bends towards or away from the ground.